Hello IPXers, Electronica 2024. This is our first video with William from Nanopower. We constantly are looking for disruptive technology, things that you don't know about, things that you haven't seen. We've walked onto their booth, this is disruptive. So William, if Nanopower didn't exist, what would design engineers at OEMs be doing today?
Yeah, if we didn't exist, they were still using standard technology, which doesn't allow a system to avoid power consumption when doing nothing. So normally battery operated long-term monitoring systems, they don't measure, they don't do all the time something, they are doing nothing most of the time.
But they're still burning power.
They are still burning power. So with our technology, we are able to reduce this power to a few nanowatts, which is nothing. Right. Compared to what they have now.
Right. So just describe what would be a typical system where you're describing that they're still drawing power, although they're doing nothing. Where would be a typical application where you would see that today?
Yeah, I can show you this one. We are demonstrating this. We have a demo, which is basically more or less a home automation monitoring system. Right. Where if you want to control your home in ambient, so we have a temperature, luminosity, pressure, and relative humidity. We are measuring this.
So a typical industrial type sensor.
Industrial or home.
Or home sensor.
If you want to control your home with HVAC, so we are able to monitor such parameters once a second, and we are able to turn off the power of all the sensors when you don't need them in between the seconds. Right. So we're talking about very, very small amounts of time. Yes. But then added up over a period of time, that's drawing power down all the time. Yes. So we are able to monitor the sensors and only send data out if a threshold is above or below something that was set. So we don't need to send information which it's not important, which is the same as it was on the past. So we only trigger information out when it's needed to the system. Right. So in other words, for our community, it's at the point that where you've said this data is critical, as in not critical about dangerous, but it's at the point that you set the threshold. Yes. And it's at that point that it will then kick in, take the data, and then send the data. Not only because I know that system designers, they want to have keep alive information, and we also have the possibility to send keep alive messages from in 5 to 5 minutes or 10 to 10 or whatever. They feel safe that they know the system is operating, because if you only send data when something changes, and if it never changes, it might never work in the next year, but people want to know it's working. So in this example here that we are talking now, we just sent a 5-minute keep alive session, so we know that in our home, in this case, we are measuring all the variables we need. Right, right. And is this at the point that the data needs to be sent, or is that one of those presets? This is a preset. That's the preset one? Yeah, the preset one. So okay, good. So we've talked about, so just explain a little bit more about, you've explained the environment where if you didn't exist. Yes. So how do they integrate that? What would they have now that would be doing that job? And then what's the difference between what they've got now to what you would deliver to them? Yeah, so now the system designer, they normally have a host in the system which sends data BLE, Wi-Fi, LTE, whatever, and they control the sensors directly. So the host is in direct contact with all the sensors. Right. We act in between. So our device will be a kind of a sensor to the host, and will be a master to all the sensors. So we shut down the host. We receive a kind of a recipe on how to operate all the sensors. We shut down the host, and we take control of all the peripherals. Right. Okay. Right. We have industry standard communication protocols like I2C and SPI, which are standard in such sensors, and we take care of all the system with much lower power. When something happens, as I said before, we wake up the host. We send all the information already clean to the host, and he picks up the information, sends out via Wi-Fi, BLE, whatever. Okay, one last quick question then. Yep. If you're, I mean, what you're describing is something that's probably been there for quite a while. So from a time-wise, in terms of manufacturing time, that's quite a in-place, ready legacy system. What's the integration issues that they have to take into account
when they go, we're going to go with a Nanopower solution because we like this idea of saving power. We like this idea of, I can't remember the phrase you used, but it described at a point, a certain point that you send I can't remember what the phrase was that you used, but anyway, whatever that phrase was.
Information out.
Yeah, every 10 minutes, every 15 minutes.
They keep alive.
Or yeah, the keep, is that a phrase, the keep alive?
Yeah.
Yeah. Or at the point that something comes in, it says, I need to send that data.
Yes.
Because you're putting something into the system. So what is the integration issues? What do they have to think about when they do that?
So we thought on that because by core, I'm an engineer also, and integration and embedded engineer. And I don't like, when I was doing integration, I didn't like to have different SDKs to do something.
Yeah.
If you use a wireless chip, you have a SDK. If you have something else, nowadays you need another SDK. You have a bunch of SDKs to operate. We thought on this. We made our system to behave as a normal slave. Okay.
Yeah.
We provide an API, a C, and a header file, and they just
so the system will just recognize you straight away.
Yes, straight away. So we provide the API and the driver, so they immediately understand how to operate with this.
Yeah.
Even more, if you go to that screen, we have here an app where people can configure. This is an evaluation board that we provide to customers, where the customer, without doing any code, he doesn't need to use his system to operate. We have an app where he can configure all the registers and all the operation mode without even knowing how to code.
Yeah.
This is all graphical.
Yeah.
So
it's already embedded. It's agnostic already.
Yes.
And it's already embedded into the system and the chip.
Yes. So you just need to tick boxes, understand more or less what you want to do. You just plug in the sensors, and it automatically burns the code, the behavior of our chipset, and it will automatically manage all the sensors, and they can measure the current in real time immediately. They don't need to lose time. So the idea is someone unboxes this, he plugs the USB to the laptop, installs the app, and in 5 minutes he is testing the truth we are telling him, how low he can go down in power immediately. Okay.
So this won't be. It's a disruptive technology, but this won't disrupt an already legacy design. It will automatically integrate in and just understand, and what is already there, you just called it a slave, it will already know, and it will already start doing its job the moment you plug it in.
Immediately, yes.
Excellent. So just tell us quickly about evaluation. So you've listened to the video, you've gone, I've got an industrial system, home automation system. I like the idea of less power. I like the idea of it being off and not burning, even though it's tiny amounts of power. But over a 24-hour period, over a 7-day period, over a 12-month period, that's actually a lot of power. So just tell us about how they can come to you. Obviously, the answer to that is ipXcahnge.tech, ipXcahnge.tech. But just tell us quickly about what evaluation systems you've got so that they can come and play with it.
Okay, so this is an evaluation kit.
Yep.
Basically, what we have here is a carrier board which is already populated with our sensor and compatible with the app. We have a Arduino Uno pinout, which is compatible with everything.
Everything. Yeah.
We also have two types of PMOD connections, a half and a full PMOD, which we can connect a host, several hosts, I2C and SPI. So it's plug and play immediately with off-the-shelf sensors you can buy anywhere.
Yeah. This is well thought through. We
also provide in the same kit some sensors if people want to try out immediately without buying or whatever. They already have some sensors to test, temperature and pressure and so on. We also have a Cortex M3 to test without radio, but it's easy to put here any type of Arduino Uno type compatible shield, and you are ready to go.
William, thank you for our first interview at Electronica 2024.
Thank you.
Brilliant.
Nice talking to you. Bye-bye.